guys, welcome back to TechDose, and in this video we will look at the shortest subarray with or at least k2 problem, which is from Leetcode number 3097, and we will be looking at the optimal solution. Let us now look at the problem statement. In this problem you are given an array nums of non-negative integers and an integer k. An array is called special if the bitwise OR of all of its elements is at least k. Return the length of the shortest special non-empty subarray of nums, or return -1 if no special subarray exists. Now before looking at an example, let's look at the constraint. In this case, the size of the array is less than equals to 2 times of 10 to the power of 5. So since we know that we have to do less than 10 to the power 8 operations, so we cannot go with an n square algorithm, but you can go with n or n log n algorithm. And each of the item is within the integer range, and the k value will range from 0 to 10 to the power of 9 as well. Now let's look at an example for better understanding. In this case, let's say our array is 132041, and these are the binary representation of all the elements. Our goal is to find the shortest subarray with OR value greater than equals to k. Now here the k value mentioned is equals to 5. A similar problem is find shortest subarray with sum less than equals to k, which is from Leetcode number 862. I have already made a video on this. You can go and watch from the link in the I button or also in the description below. Now in this problem, if you want to find out the shortest subarray with OR value greater than equals to k, the simplest approach would be to generate all possible subarrays. That means subarrays starting with this index 0. So there will be n such subarrays. Then the subarrays starting with index 1. There will be n minus 1 such subarrays, and you can just keep on adding all the possible subarrays. It will be order of n square subarrays. And then compare the OR values and the size and see which one is the smallest subarray with the OR value greater than equals to k, and return the answer. So the time complexity will be order of n square in this case. Now if you solve this problem, then you will have multiple options where you can get an OR value greater than equals to 5. You can have the entire array itself, or you can have 4, 1, or you can have 0, 4, 1, or you can have 1 to 4. All these subarrays, and you can have even more combinations, can give you the OR value greater than equals to 5. But which one is of smallest length? It is of length 2, which is 4, 1. Okay, so the answer in this case will be 2. If let's say there was an item, let's say 6, then it will always be possible to have just a single item, and you can take just a single item to say that the bitwise OR will be greater than equals to k, so the length will be 1. So if in the array you have an element which is greater than equals to k, then the answer will always be 1. Otherwise it will be greater than 1 if possible. All the time it will not be possible. You can look at an example having 2, 1, 3. Now in this case, if the k value is equals to 5, then you will never get the OR value greater than equals to 5. You can OR all these values, and what will you get? With 2, 1 and 3, you will get 3 only, right? You cannot get a value greater than equals to 5, and hence the answer will be -1. So I hope the problem statement is clear here. Now before looking at the solution, let's look at some observation. The first observation is about the OR property. It does not matter how many times you have seen a 0, but you have seen a 1 at least one time, then the bit will always be set while taking the OR operations, right? And since all the numbers are positive, therefore if you take the OR between the positive numbers from left to right, then the OR value will continuously keep on increasing. It will be a non-decreasing curve. Like let's take the previous example of 132041. So if you plot it on a graph, then you will see that the value will always be continuously increasing. Like the first value being 1, the OR value will be 1. If you take the second value ORed with the first value, the OR value will be 3 or 1, which is 3. If you take 2 and OR it with the previous OR value 3 or 2, it will be 3. Then if you take the 3 or 0 will be 3. Then if you take 3 ORed with 4, then you will get a value 7. And if you take 7 ORed with 1, then the value will still be 7, right? So you see this curve is non-decreasing. In such kind of curve, if you want to find any smallest or largest subarray, then you can apply the simple sliding window approach. Okay. Now let's see how to apply sliding window with the OR technique. If it was a simple plus operator, like I was just finding the smallest subarray with sum greater than equals to k, something like that, then in that case, if I want to slide this r to the right hand side, then I can simply add this value, and if I want to move this l to the right hand side, then I can simply subtract this value 3, right? But in this case, the operator is different. It is not plus. If it was plus, then while moving to the right, I will do plus, and while moving the left pointer to the right, I will do minus. But while doing the operation with OR, you can easily slide the right pointer to the right hand side by doing OR with the current OR value. Like what was the OR value for this window? It was 3 ORed with 2 ORed with 0. So that will be 3. So the current OR value here was 3. And if you want to include this 4, then you will take this 3 and OR it with 4 and you will get a 7. So you can easily slide it by ORing this 3 with 4 and you will get a 7 value. But how will you slide this left pointer to the right hand side? You cannot subtract it, and there is no inverse operation of this OR that you can directly apply, and therefore in order to remove this, it is not a trivial operation. Okay, you cannot just do it in one step. So what you have to take care is, you have to see the property number 1 where it says that if you have seen at least a single 1, the answer will always be a set bit, right? Based on that, if you consider this window 3 to 0, then you have these bits, right? The 0th bit and the first bit. Here for 3, both the 0th and the first bit is set. For 2, only the first bit is set, and for 0, no bits are set. So if you want to remove this 3, then this one here will be gone, right? And you will be left with 1 0 and 0 1, and you will be appending this 4 to the right hand side. So 4 is 1 0 0, right? So you will be appending it, and then you can find a new OR value. So in order to implement sliding window, you have to keep a count of frequency of the set bits for each and every position. Okay, so this is a non-trivial operation. What you have to do is, let's say for this window, the bit position 0 1 2, we are tracking, let's say, only 3 bits. Technically you have to track 32 bits, right? And let's say all of them were zeros initially. But for this window, when you have 3 to 0, then you know that for this 3, these 2 bits were set, so I will set 1 1, and then for this 2, only the first position was set, so I will increase the counter to 2. For 0, no bits were set. Now at this point of time, for the 0 1 2 positions, you have the count as 1 2 and 0, and the rest all values are zeros, right? If you want to slide it to the right hand side, what is the bit representation of 4? 1 0 0. What are the position? 0 1 2. So the second bit is set. So for the second bit, increment the counter by 1. This is how we slide to the right hand side. And in order to slide this left variable to the right hand side, we want to remove this 3. So what is the representation of 3? It is 1 1, and the bit positions being 0 and 1. So at this position 0 and 1, we will be decrementing the counter by 1 time. Okay, so effectively this window 204 is representing 0 1 0 0 0 0 and 1 0 0. So if you count the frequency of bit positions, that means the set bits, it will be 0 count, 1 count and 1 count, right? So you see that I have at position 0 0 count, at position 1 1 count, and at position 2 1 count. You can also retrieve the number using that. If the count is greater than 0, then that bit will be set in the OR value. That means the window OR value, right? Here the window OR value. Now if I tell you that the 0th bit has 1 count, first bit has 2 count, second bit has 0 count, and all the rest of the bit have 0 count of set bits. Extract the number. What will be the value here? So it will be, this bit will be set. This 2 means there are 2 set bits, means what? 1 OR with 1 will be 1 only. So I will be setting this bit and all the bits will be zeros. This is the least significant bit and this is the most significant bit, right? So what will be the value? The value will be 3 in this case, right? So in the previous window, 3 or 2 or 0, the value was 3 only, right? So these are the 2 functions that I need to write. The first function is keeping track of the sliding. So when we slide to the right hand side, I will be incrementing the counters, that means the bit counter. And when I move this left variable to the right hand side, then I will be decrementing the bit counter. Now let's implement this idea and see a dry run of the entire approach using the sliding window 2-pointer technique. In this case, I will be taking the same example, and these are the bit representation for reference, and my k value is equals to 5. Initially, I will be starting my left variable with the pointer position 0 and the right variable with 0 as well. The shortest subarray size will be infinity because I want to minimize this, and I will keep a bit frequency counter for counting the set bits in the current window ranging from the left pointer to the right pointer. And initially all the count of set bits will be 0. I will be taking the current OR value, which is actually the window OR value. Okay, what is the OR value of the current window? And I will start with a 0. So when I see the right element, then I will be doing current or with the array at right. And so I will take or between 0 and 1 and this will become 1. Now I need to do the adjustment in the bit frequency counter. So I will find the binary representation of 1 and that will be equals to, let's say, 001. So at bit position number 0 there is a set bit, so I will increment the counter at position number 0. Okay, and the next thing I will do is I will check if the current or value is greater than equals to k. It is not, so I will not move the left pointer. In the next iteration I will move the right pointer to the next position and I will take the or value with 3. So 1 ORed with 3 will be equals to 3, right? So the current or value will now become 3. Since I am sliding the right variable to the right hand side, that means I am including more items into my window, and that is why the bit frequency counter have to be increased. What is the value of this 3? It is 11. So 11 means at position number 0 and at position number 1 we have a set bit. So I'll increment the count of set bits by 1 at position 0 and position 1. Now the shortest will not be updated because the current or is not greater than equals to k, and also I will not adjust the left pointer for the same reason. Now I will move the right pointer to the right hand side. Now I am seeing a 2. So 2 means 010. Now in this case I will be taking 2 ORed with 3 and the result will be 3 itself. Now since I am sliding the right pointer to the right hand side, I am including 2 into my window. So what is the representation? 010. So position 1 bit is set. So position 1 counter has to be increased by 1. Fine. Now I will be going to the next item. This is 0. 0 ORed with 3 will still remain to be 3. So no change is happening. Now 0 is included. Now you do not have any set bit in 0. So no update in bit frequency counter. When you move this right pointer to 4, now 4's representation is 100. The previous current or value is 3, which is 011. So if you take OR with 100, you get 111, which is 7, right? So you update this to a value 7. Now you will update the bit frequency counter because this is 4. So the second bit position is set here. So you will be adding 1 to the frequency counter here, right? And since the current or value now is greater than equals to k, so I will be updating my shortest value and make it to r minus l plus 1. That means 4 minus 0 plus 1, the window size is 5. So update this window size to 5. Now I will adjust this left pointer, keep pushing the left pointer to the right until this left pointer hits the right pointer. That is first condition. That means L should always be less than equals to R. And the second condition is my current or value should be greater than equals to K. If it is less than K, then I will stop. Okay. Now let's move this left pointer to the right hand side. If you do that, then I have to remove this 1 from the window. If you remove this 1, see the bit representation 001. Which bit is set? Position number 0. So I have to decrease the counter of position number 0 by 1 time. Okay. And after doing that, I will be finding out what is the current value of the OR here. So you see it is saying that at bit position number 0, we have 1 set bit. At bit position number 1, we have 2 set bit. At bit position number 2, I have 1 set bit. And all the other bits are 0. This means that with the OR property, you know that if there is at least 1 set bit, the bit will be set at that position. So I will use that property and set the bits at position number 0, 1, 2. And the value will be 7 here, right? So the current or value is not changing. Again, what is the shortest window size? R minus L plus 1. 4 minus 1 plus 1 will be 4. So 4 is better, so I'll update this. Again, this left pointer has to be adjusted and we will move to the right hand side because the current OR is greater than equals to K and also left is less than equals to R. So now when you move it to the right hand side, then this 3 has to be removed. The bit representation of 3 is 011. At position 0 and 1 there were set bits, so I have to reduce the set bit count at 0 and make it 0, and at 1 it will be reduced by 1. Now again I will get the number. So if I get the number at 0, I have 0 set bit now. So I will keep a 0 bit at position number 0. At position number 1 we have 1 set bit, so it will be 1. At position 2 I have 1 set bit, so this will be 1. Now what is this value? 110. It is 6. So this value will be updated to 6. Okay, now this 6 is greater than equals to 5. So definitely we need to update this shortest variable as well. So this will be R minus L plus 1. 4 minus 2 plus 1 is 3. So update this to 3, which is a smaller size, right? Now again I will be moving this to the right hand side. 2 will be removed. The representation is 010. At position number 1 there is a set bit. So at position number 1 I will reduce the bit because it is going out. 2 is going out. Now only the second bit is set, otherwise all the other bits are unset. So in that case, my number becomes 100, which is 4. So this number will become 4, right? And since this current OR is less than k, so I will not be updating the shortest window right now. Fine. Now since I have gone to a number which is less than k, so I'll be moving this right pointer to the right hand side, and I will be including this one. Including this one is having a bit 001, and at position number 0 we have a set bit. So at position number 0 I will be incrementing the counter. So this counter will become 1. At position 1 I already have a 0. At position 2 I have a 1. So what is this number? At position 2 you have 1. At position 1 you have 0. And position 0 you have a 1. So this number is 5. Okay, so update the current OR value to 5 simply. Now we can check that the current OR value is greater than equals to k. So the window size is 5 minus 3 plus 1, which is 3. So we already have a 3 window size, so no change will happen. Now I will move this left pointer to the right hand side because current OR is greater than equals to k, and 0 will be removed. So 0 do not have any set bit, so it will not affect the bit frequency counter, and I will still have the value 5. Now since we have a value 5 which is greater than equals to the k value, so again we will take the shortest window, which is 5 minus 4 plus 1, so that will be 2, and 2 will be updated here, right? Now again I will be moving this left pointer to the right hand side, and 4 will be removed. So in 4 we have the second bit position as set, so that will become unset now, and we will make it 0. So now the value becomes 001, and 001 is equals to 1, so the current OR value becomes 1. So in that case I will be moving the right pointer to the right hand side, and since I am going out of bound I will stop, and my answer is the shortest window size, which is 2. Okay, so I hope you were able to understand this problem. Now in this case, if you analyze the complexity, then I am going for all the elements exactly one time from left to right. So order of n for that. And for every element I am incrementing or decrementing the bit frequency counter, and this is of maximum size of 32. So you can say that the time complexity is 32 times of n, or you can say order of n. But you know that the log n base 2 value of the integer maximum is 32. So the runtime will be n log n, but amortized time is order of n. And the space complexity can be considered to be order of 1 because we are taking a constant size of bit frequency array. Now let's look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this code, there are two utility functions given the bit frequency array and the number with the given value. That means whether you want to increment it by 1 or decrement the value by 1. We will be iterating for all the bits and finding out if the ith bit is set in the given number. Then I will add +1 or subtract -1 from the given bit frequency counter. Depending on if the right pointer is moving to the right, then I will do +1, or if the left pointer is moving to the right hand side, then I will be doing -1. You know, because if left pointer moves to the right, then I will be removing the current item, but if you move right pointer to the right hand side, then I'm including the new item, right? So just to accommodate both of them in the same piece of code, I have done that. Then you see this get number given any bit frequency array, like the bit frequency array was from 0 to 31. So if I say that 101 is the bit frequency array, then what will be the number? Or maybe 102, then what will be the number? It will be, if this frequency is greater than 0, then I will add its weightage, which is 2 to the power of 0. If this frequency is not set, then it will not be counted. If this frequency is at least greater than 0, then I will add its weightage, which is 2 to the power of 2. So this number here will be 1 plus 4, which will be 5. For 102 you will get 5. Okay, so this is that utility function to get a number from the bit frequency array. Now this is the main minimum subarray length function, where we will get the nums array and we will get k. If k is 0, then I will return a length 1, because it will always be possible whatever number you include, because all the numbers are greater than equals to 0. Now I'll be finding the size of the nums array, keeping the shortest value to infinity as I said, and then the left and right pointer will start at 0 and the current OR will also start at 0. The bit frequency counter will have all the default value as 0. And this is the two pointer approach, where we will move until the right goes out of bound. So as soon as I see an element, I will be updating the frequency of the bit in the bit frequency array. You see here I have passed a +1 value, because if the right pointer moves to the right, I will be including a new item, so all the set bit position frequencies have to be increased. Then the current OR will also get updated. Now if left is less than equals to right, and also the current OR is greater than equals to k, then I will be computing the shortest window size, and then I will be updating the frequency by moving the left pointer to the right hand side, finding out the set bit positions for this x and decrementing a value 1 from the bit frequency array, and then again recalculating the current OR value by getting the number using the bit frequency array, and then moving the left pointer to the right hand side. So this is the entire implementation. After this, if you could not find any shortest window size, then your answer will be -1, because there is no such window. Otherwise you will return the shortest window size. So I hope you were able to understand this. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. Like and share our video and subscribe to our channel in order to watch more of these programming videos. See you guys in the next video. Thank you.